Hi everyone, welcome to Studia Academy Past Paper Walkthrough. In this video, we will be discussing IGCSE Excel Maths A, May 2024, Paper 2H. Question 1. We've got 8 numbers in order. H, 6, 7, 8, J, 16, K, K. We're told H, J, and K are integers, and we need to work out their values using the median, mode, and range. First, we're told the median is 10. With 8 numbers, the median is the average of the 4th and 5th numbers. Looking at the list, the 4th number is 8 and the 5th is J. So we set up the equation. 8 plus J over 2 equals 10. Solve that and you get J equals 12. Next, the mode is given as 18. The mode is the most frequent value. In our list, the only repeated numbers are the 2 K's at the end. That means K must be the mode, so K equals 18. Finally, the range is 13. Range is the largest number minus the smallest number. The largest number is now 18 and the smallest is H. So 18 minus H equals 13, which gives us H equals 5. For question 2, we're working with straight line graphs and inequalities. Part A asks us to draw 3 lines on the grid. First, y equals 2. This is a horizontal line. It passes through every point where the y-coordinate is 2, so we draw a straight horizontal line crossing the y-axis at 2. Second, x equals 6. This is a vertical line. It passes through every point where the x-coordinate is 6, so we draw a straight vertical line crossing the x-axis at 6. Third, y equals x plus 1. This equation is in the form y equals mx plus c. Here the gradient m is 1, and the y-intercept c is 1, so the line crosses the y-axis at the point 0, 1. From there, because the gradient is 1, we go up 1 and right 1 to plot another point, then draw the straight line. Make sure to label each line clearly with its equation. Part B asks us to show the region that satisfies all 3 inequalities. We're going to shade the region that meets all 3 conditions. For y is greater than or equal to 2, we want the region above or on the horizontal line, y equals 2. For x is less than or equal to 6, we want the region to the left of or on the vertical line, x equals 6. For y is less than or equal to x plus 1, we want the region below or on the diagonal line, y equals x plus 1. The region that satisfies all 3 is the overlap of these 3 areas. Once you've identified it, shade it in and label it R. Next, question 3. We're told a plane takes 9 hours 36 minutes to fly from New Delhi to Perth, and it flies at an average speed of 820 kilometers per hour. We need to work out the total distance. First, we need the time in hours. The flight takes 9 hours 36 minutes. To convert 36 minutes into hours, we divide by 60, which gives us 0.6 hours. So the total time is 9 plus 0.6 equals 9.6 hours. Now, we multiply speed by time. The speed is 820 kilometers per hour, and the time is 9.6 hours. So 820 times 9.6 equals 7,872. Therefore, the total distance the plane flies is 7,872 kilometers. Moving to question 4. We need to show that 2 4/7 times 3 1/9 equals to 8. First, we convert the mixed numbers into improper fractions. For 2 4/7, we multiply the whole number 2 by the denominator 7, which gives 14. Then add the numerator 4. That gives us 18 over 7. For 3 1/9, we multiply 3 by 9 to get 27. Then add the numerator 1, giving us 28 over 9. So now we have 18 over 7 times 28 over 9, which equals to 8. Therefore, we have shown that 2 4/7 times 3 1/9 equals 8. Now for question 5, we have a right-angled triangle ABC, and we need to work out the value of x, giving our answer to 1 decimal place. Let's identify the sides in relation to the given angle of 34 degrees. The hypotenuse is the longest side, which is 6.5 centimeters. The side opposite the angle is x centimeters. We're not given the adjacent side. To choose the correct trigonometric ratio, we use SOHCAHTOA. SOH stands for sine equals opposite over hypotenuse. CAH stands for cosine equals adjacent over hypotenuse. TOA stands for tangent equals opposite over adjacent. Since we have the opposite and the hypotenuse, we use sine. So we set up the equation. Scene 34 degrees equals x over 6.5. Now solve for x. Multiply both sides by 6.5. This gives us x equals 6.5 times scene 34 degrees. Make sure your calculator is in degree mode. Calculating this gives x equals 3.6347, and so on. Rounding to one decimal place, we get x equals 3.6. Now let's look at question 6. We need to change a speed of w meters per second into kilometers per hour, giving our answer in terms of w in its simplest form. To do this, we convert the units of distance and time separately. First, convert meters to kilometers. Since 1 meter is 1,000th of a kilometer, w meters is w over 1,000 kilometers. Next, convert seconds to hours. There are 3,600 seconds in 1 hour, so 1 second is 1 over 3,600 of an hour. Now, speed is distance divided by time. So w meters per second becomes ew over 1,000 divided by 1 over 3,600. Dividing by a fraction is the same as multiplying by its reciprocal. So we have w over 1,000 times 3,600 over 1. This gives us 3,600 w over 1,000. Now, let's simplify. Cancel the zeros to get 36w over 10. This simplifies further to 18w over 5, which is also equal to 3.6w. So, the speed in kilometers per hour is 18w over 5, or 3.6w. Either form is acceptable in its simplest terms. Moving on to question 7. We have a six-sided shape, A, B, C, D, E, F. We know that AF is 21 centimeters, CD is 15 centimeters, and both AB and FE are 13 centimeters. The total area of the shape is 390 square centimeters, and we need to find the total perpendicular height, h. We can solve this by splitting the shape into two simpler parts, a rectangle at the bottom and a trapezium on top. First, let's identify the bottom rectangle. This is bounded by the base A to F and the vertical sides A to B and F to E. Its width is 21 and its height is 13. So, the area of the rectangle is 21 times 13, which equals 273 square centimeters. Next, we find the area of the trapezium by subtracting the rectangle's area from the total area of the shape. That's 390 minus 273, which gives us 117 square centimeters. Now we need to find the height of the trapezium. Let's call this height x. The formula for the area of a trapezium is the sum of the parallel sides divided by 2 times the height. Our parallel sides are 15 and 21. 15 plus 21 is 36. 36 divided by 2 is 18. So our equation is 117 equals 18 times x. Dividing 117 by 18, we find that x equals 6.5 centimeters. Finally, the total height h of the shape is the height of the rectangle plus the height of the trapezium. That is 13 plus 6.5. So the value of h is 19.5. Let's work through question 8. Ishir plants 600 bulbs in total, with tulip, crocus, and daffodil bulbs in the ratio 9:4:2. We need to find the number of bulbs that produce yellow flowers. First, we split the 600 bulbs according to the ratio. The total number of parts is 9 plus 4 plus 2, which equals 15 parts. To find the value of one part, we divide 600 by 15, which gives us 40 bulbs per part. Now we can find the total number of each type. For tulips, 9 times 40 is 360 bulbs. For crocus, 4 times 40 is 160 bulbs, and for daffodils, 2 times 40 is 80 bulbs. Next, we calculate how many of each are yellow flowers. For tulips, 45% are yellow, so 45% of 360 or 0.45 times 360 is 162. For crocus, 5/8 are yellow. 5/8 of 160 is 100. For daffodils, all of them are yellow. So that's 80. Finally, we add them all up to find the total number of yellow bulbs, 162 plus 100 plus 80. This gives us a final total of 342. So the number of bulbs for yellow flowers is 342. Let's look at question 9. Giovanni invests 4,500 koruna in a savings account for 4 years at a compound interest rate of 2.4% per year. We need to work out how much money he'll have at the end of the 4 years, rounding our answer to the nearest koruna. To solve this, we use the compound interest formula. First, let's determine our multiplier. An increase of 2.4% is the same as 100% plus 2.4%, which is 102.4%. As a decimal, that is 1.024. Now, we set up our calculation. We take the principal amount of 4,500 and multiply it by 1.024 raised to the power of 4 because the money is invested for 4 years. On your calculator, that looks like 4,500 times 1.024 to the power of 4. This gives us approximately 4,947.80. The question asks for the answer to the nearest koruna. Since our decimal is 0.8, we round up to the next whole number. So at the end of 4 years, Giovanni will have 4,948 koruna. Next, question 10. Let's solve these simultaneous equations. Our first equation is 6x plus 4y equals 1. Our second equation is 3x plus 5y equals 8. We can use the elimination method to solve this. Notice that 6x is a multiple of 3x. To make the coefficients of x the same, we'll multiply our second equation by 2. Multiplying the entire second equation by 2 gives us 6x plus 10y equals 16. Let's call this our third equation. Now we subtract the first equation from this new third equation. On the left side, 6x minus 6x is 0, and 4y minus 10y gives us negative 6y. On the right side, 1 minus 16 gives us negative 15. So we have negative 6y equals negative 15. Dividing 15 by negative 6, we find that y equals 2.5. Now that we have y, let's substitute 2.5 back into our second equation to find x. That gives us 3x plus 5 times 2.5 equals 8. Since 5 times 2.5 is 12.5, the equation becomes 3x plus 12.5 equals 8. Next, subtract 12.5 from 8. That gives us 3x equals negative 4.5. Finally, divide negative 4.5 by 3. We find that x equals negative 1.5. So the solution to our simultaneous equations is x equals negative 1.5 and y equals 2.5. Moving to question 11. Part 1 asks us to factorize the quadratic expression, x squared plus 9x minus 22. To factorize an expression in this form, we need to find two numbers that multiply to give the constant term, which is negative 22, and add to give the coefficient of x, which is 9. Let's look at the factor pairs of negative 22. First, we could try negative 1 and 22. Their sum is 21, so that doesn't work. Next, we could try 1 and negative 22. Their sum is negative 21. Still not quite right. Now let's try negative 2 and 11. Their sum is 9. That is exactly the pair we are looking for. Since negative 2 plus 11 equals 9, and negative 2 times 11 equals negative 22, we can now write our factors. The expression factorizes to x plus 11 in brackets times x minus 2 in brackets. Now for part 2. The word hence tells us we should use the result from the previous part to solve the equation. From part 1, we factorize the expression into x plus 11 in brackets times x minus 2 in brackets. Now we set this equal to 0. For the product of two brackets to be 0, at least one of the brackets must be equal to 0. So our first possibility is x plus 11 equals 0, which means x equals negative 11. Or our second possibility is x minus 2 equals 0, which means x equals 2. Therefore, the solutions to the equation are x equals negative 11 or x equals 2. Now, for question 12. Ali uses a fitness tracker to count his steps over 7 days. For the first 4 days, his mean number of steps is 11,800. For the next 3 days, his mean is 13,207. We need to find his mean number of steps for the full 7 days. First, we need to find the total steps for the first 4 days. Since the mean is the total divided by the number of days, we multiply the mean by 4. 11,800 times 4 gives us a total of 47,200 steps. Next, we find the total steps for the next 3 days. We multiply that mean by 3. 13,207 times 3 gives us 39,621 steps. Now we add these two totals together to get the grand total for all 7 days. 47,200 plus 39,621 equals 86,821 steps. Finally, to find the mean for the full 7 days, we divide that grand total by 7. 86,821 divided by 7 equals 12,403. So Allie's mean number of steps for the 7 days is 12,403. Next, question 13. We have a table showing the distances 70 teachers travel to school with grouped frequency data. Part A asks us to complete the cumulative frequency table. Remember, cumulative frequency means we find a running total of the frequencies as we go down the list. Each row represents the total number of teachers who travel up to that specific distance. For distances up to 10 kilometers, the cumulative frequency is just our first group, which is 7. For distances up to 20 kilometers, we add the next group of 17. So 7 plus 17 gives us 24. For distances up to 30 kilometers, we add the next group of 18. 24 plus 18 equals 42. For distances up to 40 kilometers, we add 14. 42 plus 14 equals 56. For distances up to 50 kilometers, we add 10. 56 plus 10 equals 66. And finally, for distances up to 60 kilometers, we add the last group of 4. 66 plus 4 gives us a final total of 70. So our completed cumulative frequency table now shows our running totals ending at 70. Part B asks us to draw a cumulative frequency graph, which is also known as an ogive. When plotting this type of graph, we use the upper bound of each distance group for the x-axis and our cumulative frequency totals for the y-axis. Our points to plot are 10, 7, 20, 24, 30, 42, 40, 56, 50, 66, and 60, 70. It's also good practice to include the starting point at 0, 0, since 0 teachers have traveled less than 0 distance. Once your points are plotted, join them with a smooth S-shaped curve. Avoid using a ruler to connect them in straight lines unless specifically instructed. This smooth curve gives us the final cumulative frequency graph. Part C asks us to find an estimate for the interquartile range. The interquartile range measures the spread of the middle 50% of the data. Since there are 70 teachers in total, we need to find the values at the lower and upper quarters of the cumulative frequency. First, to find the lower quartile, or Q1, we calculate 1/4 of the total frequency. 1/4 of 70 is 17.5. On your graph, find 17.5 on the y-axis. Move horizontally to the curve, then vertically down to the x-axis. This gives us an estimate for Q1 of approximately 16 kilometers. Next, to find the upper quartile, or Q3, we calculate 3/4 of the total frequency. 3/4 of 70 is 52.5. Find 52.5 on the y-axis, move horizontally to the curve, and then vertically down to the x-axis. This gives us an estimate for Q3 of approximately 37 kilometers. Now we calculate the interquartile range by subtracting Q1 from Q3. 37 minus 16 equals 21. So the interquartile range is 21 kilometers. Finally, for Part D, we need to estimate the number of teachers who travel more than 46 kilometers. First, we need to find how many teachers travel up to 46 kilometers. To do this, locate 46 on the x-axis, move vertically up to the curve, and then horizontally across to the y-axis. This gives us a cumulative frequency of approximately 62. That means 62 teachers travel 46 kilometers or less. To find the number of teachers who travel more than 46 kilometers, we simply subtract this number from the total number of teachers. 70 minus 62 equals 8. So our estimate is that 8 teachers travel more than 46 kilometers. Move to question 14. Part A asks us to show that 3y multiplied by the two brackets 2y plus 5 and y plus 7 can be written in the form a minus y cubed plus by squared plus cy. First, let's expand the two brackets. 2y plus 5 times y plus 7. We multiply each term in the first bracket by each term in the second. 2y times y gives us 2y squared. 2y times 7 gives us 14y. 5 times y gives us 5y, and 5 times 7 gives us 35. Now we combine the like terms. 14y plus 5 equals 19y. So our expanded brackets are 2y squared plus 19y plus 35. Next, we need to multiply this entire result by the 3y outside the brackets. 3y times 2y squared gives us 6y cubed. 3y times 19y gives us 57y squared, and 3y times 35 gives us 105y, so our final expression is 6y cubed plus 57y squared plus 105y. Therefore, our integers are a equals 6, b equals 57, and c equals 105. Part B asks us to solve an equation involving fractions. We have 2x plus 3 over 5 plus 6, x minus 5 over 4 equals 163 over 100. First, we need to find a common denominator for the two fractions on the left. The lowest common multiple of 5 and 4 is 20. To rewrite the first fraction with a denominator of 20, we multiply both the numerator and denominator by 4. This gives us 4 bracket 2x plus 3 close bracket all over 20. To rewrite the second fraction, we multiply by 5. This gives us 5 bracket 6x minus 5 close bracket all over 20. Now we can combine them into one single fraction over 20. Our equation becomes 4 times 2x plus 3 plus 5 times 6x minus 5 all over 20 equals 163 over 100. Next, let's expand the numerators. 4 times 2x plus 3 gives us 8x plus 12. 5 times 6, x minus 5 gives us 30x minus 25. Combining these like terms, 8x plus 30x is 38x, and 12 minus 25 is negative 13. So our simplified fraction is 38x minus 13 over 20. Now we solve the full equation. To clear the fractions, we can use cross multiplication. This gives us 100 times 38x minus 13 equals 163 times 20. Expanding the left side, we get 3800s minus 1300. On the right side, 163 times 20 is 3260. Now add 1300 to both sides. This gives us 3800, x equals 4560. Finally, divide 4560 by 3800. The result is x equals 1.2. Now, for question 15, Part A asks us to make g the subject of the formula. E equals the square root of 7g plus 5 over 11 plus 2, g. First, we need to remove that square root, so we square both sides. This gives us e squared equals 7g plus 5 over 11 plus 2g. Next, let's clear the fraction by cross-multiplying. This gives us e squared times the bracket 11 plus 2g equals 7g plus 5. Next, we expand the left side. 11e squared plus 2e squared g equals 7g plus 5. Our goal is to isolate g, so let's group all terms containing g on the left and move everything else to the right. We subtract 7g from both sides and subtract 11e squared from both sides. This gives us 2e squared. G minus 7g equals 5 minus 11e squared. Now we factor out g on the left side. G times the bracket 2e squared minus 7 equals 5 minus 11e squared. Finally, we isolate g by dividing both sides by that bracket. So our final answer is g equals 5 minus 11e squared all over 2e squared minus 7. Move to Part B. We need to solve the quadratic inequality. 3y squared plus 4y minus 32 is greater than 0. First, we find the critical values by treating this as an equation. We need to factor the quadratic. 3y squared plus 4y minus 32 equals 0. To factor this, we look for two numbers that multiply to negative 96 and add to 4. Those numbers are 12 and negative 8. Splitting the middle term and factoring by grouping, we get the two brackets. 3y minus 8 times y plus 4 equals 0. This gives us our two critical values, y equals 8 over 3, and y equals negative 4, which is about 2.67. Now we look at the shape of the graph. Since the coefficient of y squared is positive, the parabola opens upwards. We want the regions where the expression is greater than 0, which means where the curve is above the x-axis. This happens in the two tail regions, to the left of our smaller root and to the right of our larger root. Therefore, the solution to the inequality is y is less than negative 4, or y is greater than 8 over 3. Let's look at question 16. We have 60 art students who were asked about workshops for knitting, photography, and embroidery. We're given several totals, and we need to complete the Venn diagram. The key here is to work from the inside out. If you start with the outer totals, you'll accidentally double count students who are in multiple groups. First, let's look at the very center of the students who chose all 3 workshops. We're told 9 students chose knitting, photography, and embroidery. So we place a 9 in the central intersection where all 3 circles overlap. Next, we look at the 2 workshop intersections. For each pair, we must subtract the 9 students we already counted in the center. For knitting and photography, 17 chose these. So 17 minus 9 equals 8. Put an 8 in the intersection of K and P only. For photography and embroidery, 16 chose these. So 16 minus 9 equals 7. Put a 7 in the intersection of P and E only. For knitting and embroidery, 20 chose these. So 20 minus 9 equals 11. Put an 11 in the intersection of K and E only. Now we can find the students who chose only 1 workshop. For photography, the total is 28. We subtract all the students already accounted for in that circle. That's 8 plus 9 plus 7. 28 minus 24 equals 4. So 4 students chose photography only. For embroidery, the total is 39. We subtract the students in the intersections involving embroidery, 11, 9, and 7. 39 minus 27 equals 12. So 12 students chose embroidery only. We aren't given the total for knitting directly, but we can find it because we know there are 60 students in total. Let's add up all the numbers we have so far, including the 2 students who chose none. 8 plus 9 plus 7 plus 11 plus 4 plus 12 plus 2 equals 53. That leaves 60 minus 53, which is 7. So we put a 7 in the knitting only section. Finally, make sure those 2 students who chose none of the workshops are placed outside the circles but inside the rectangle. To check our work, we add up every number in the diagram. 7 plus 8 plus 4 plus 11 plus 9 plus 7 plus 12 plus 2 equals exactly 60. Everything balances and our Venn diagram is complete. Part B asks, if one student is chosen at random, given that this student chose photography, find the probability that they also chose knitting. The word given is a very important clue in probability. It means we are only looking at the photography circle, and we can ignore everything else in the Venn diagram for a moment. From our original information, we know the total number of students who chose photography is 28. This will be our denominator. Within that group of 28, we need to find how many also chose knitting. This is the number in the intersection of knitting and photography. Looking back at our data, that total is 17. This will be our numerator, so the probability is 17 over 28. Since 17 is a prime number and doesn't go into 28, we can leave our answer as the fraction, 17 over 28. Part C. We need to find the number of students in the set, P intersection, K prime. In plain English, this notation means the number of students who are in photography and not in knitting. To find this, we look at our completed Venn diagram and identify all the parts of the photography circle that do not overlap with the knitting circle. There are 2 sections that fit this description. First, the photography-only section, which contains 4 students. Second, the photography and embroidery intersection, which contains 7 students. Since both of these groups are in photography but are safely outside of the knitting circle, we add them together. 4 plus 7 equals 11. So the number of students in P intersection K prime is 11. Finally, Part D. We need to find the number of students in the set, P union E intersection K. Let's break this down step by step. First, P union E means the union of photography and embroidery. This represents everyone who is in either of those 2 circles, essentially the entire combined area of both photography and embroidery. Next, we take the intersection with K. This means we only want to count the people from that large group who are also in the knitting circle. Looking at our Venn diagram, there are 3 distinct sections that fit this description. The section where knitting and photography overlap, which has 8 students. The section where knitting and embroidery overlap, which has 11 students. And the very center, where all 3 overlap, which has 9 students. To find our total, we simply add these 3 sections together. 8 plus 9 plus 11 equals 28. So the number of students in the set P union E intersection K is 28. Moving to question 17. We're told that Q is directly proportional to the square root of D. In mathematics, directly proportional means we use a constant of proportionality, which we usually represent with the letter K. This gives us our starting equation. Q equals K times the square root of D. To find the specific value for K, we substitute the information given in the question. Q equals 4.5, when D equals 324. Substituting those in, we get 4.5 equals K times the square root of 324. The square root of 324 is 18. So our equation simplifies to 4.5 equals 18K. Now we isolate K by dividing both sides by 18. That gives us K equals 4.5 divided by 18. To simplify this fraction, it's helpful to remember that 4.5 is exactly 1/4 of 18. You can also think of it as 9 over 2. Either way, when we simplify 4.5 over 18, we get K equals 1/4. Therefore, the final formula for Q in terms of D is Q equals 1/4 times the square root of D. Now for question 18. We have a straight line, P, with the equation 5y plus 2x equals 7. We need to find the gradient of a line that is perpendicular to P. First, we need to find the gradient of our original line. To do that, we rearrange the equation into the standard form, y equals mx plus c, where m represents our gradient. Starting with 5y plus 2, x equals 7, we subtract 2x from both sides to get 5y equals negative 2x plus 7. Next, we divide everything by 5. This gives us y equals negative 25x plus 75. So the gradient of line P is negative 2 over 5. Now, for perpendicular lines, the rule is that their gradients are negative reciprocals of each other, and their product must equal negative 1. To find the perpendicular gradient, we take our original gradient of negative 2/5, flip the fraction, and change the sign. Flipping 2/5 gives us 5 over 2, and changing the negative to a positive gives us our final answer. So, the gradient of a line perpendicular to P is 5 over 2, or 2.5. Now for question 19. We are working with the formula. G equals C divided by 2F minus 3H. We've been given rounded values for C, F, and H, and we need to find the lower bound for G. First, let's identify the bounds for each variable. For C, which is 8 to the nearest whole number, the lower bound is 7.5. For F, which is 6.62 to 2 decimal places, the upper bound is 6.625. For H, which is 1.2 to 1 decimal place, the lower bound is 1.15. To make the overall value of G as small as possible, we need a small numerator divided by a large denominator. To make the denominator 2F minus 3H as large as possible, we need the largest possible value for F and the smallest possible value for H. Let's calculate that denominator first. 2 times 6.625 minus 3 times 1.15. This gives us 13.25 minus 3.45, which equals 9.8. Now, we calculate the lower bound for G by dividing our smallest c by our largest denominator. That's 7.5 divided by 9.8. This gives us approximately 0.765306. The question asks for the answer to 3 decimal places. Looking at the 4th decimal digit, which is a 3, we round down. So our final answer for the lower bound of G is 0.765. Let's work through question 20. We are given 2 equations. K equals x minus y and x equals 1 over 4y. Our goal is to express the fraction 5k over x plus 2 in a specific algebraic form. First, let's perform our substitutions. We replace k with x minus yy, which gives us 5 bracket x minus y close bracket all over x plus 2. Next, we replace every x with 1 over 4y. Now the expression looks a bit more complex. We have 5 times the quantity. 1 over 4y minus y, all divided by 1 over 4y plus 2. To simplify this fraction within a fraction, we need a common denominator of 4y for both the top and the bottom. In the numerator, 1 over 4y minus y becomes 1 minus 4y squared over 4y. In the denominator, 1 over 4y plus 2 becomes 1 plus 8y over 4y. Now, our main fraction is 5 times 1 minus 4y squared over 4y, all divided by 1 plus 8cy over 4y. Because we have 4y as the denominator for both the top and the bottom, simply cancel each other out. This leaves us with a much cleaner expression. 5 times the fraction, 1 minus 4y squared over 1 plus 8y. Finally, we expand the numerator by multiplying the 5 into the bracket. 5 times 1 is 5, and 5 times negative. 4y squared is negative 20y squared. So our final answer in the required form is 5 minus 20y squared over 1 plus 8y. Comparing this to the template, we can see that A is 5, B is 20, C is 1, and D is 8. Moving to question 21, we have a square, ABCD, with a circle perfectly inscribed inside it. The sides of the square are tangents to the circle, meaning the circle fits snugly inside. The total shaded area, which is the space inside the square, but outside the circle, is 80 square centimeters. Our goal is to find the length of the diagonal A to C to 3 significant figures. First, let's define our variables. If we let x represent the side length of the square, then the diameter of the circle must also be x. This means the radius of the circle is x over 2. The shaded area is simply the area of the square minus the area of the circle. That gives us the equation, x squared minus pi times the radius squared. Plugging in our radius, we get x squared minus pi times x over 2 squared. Simplifying that further, we have x squared minus pi x squared over 4. We can factor out the x squared to make it easier to solve. We're told this shaded area equals 80, so x squared times the bracket 1 minus pi over 4 equals 80. To isolate x squared, we divide 80 by that bracket. This gives us x squared equals 80, divided by 0.2146. Calculating that out, x squared is approximately 372.7, and the length of x is approximately 19.307599. Now, we need the diagonal, A to C. In any square, the diagonal creates a right-angled triangle. Using Pythagoras, the diagonal squared equals x squared plus x squared, which is 2x squared. So we multiply our value for x squared by 2. 2 times 372.7 equals 745.4. Finally, to find the length of the diagonal A to C, we take the square root of that result. The square root of 745.4 is 27.305. Rounding to 3 significant figures, our final answer is 27.3 centimeters. Now for question 22. We have a straight line L with the equation x plus y equals 5 and a curve. C with the equation 2, x squared plus 3y squared equals 210. We need to find the coordinates where these two graphs intersect. To solve this, we'll use substitution to create a single quadratic equation. First, let's rearrange our equation of line to make y the subject. Subtracting x from both sides gives us y equals 5 minus x. Now we substitute this into our equation of curve. This gives us 2x squared plus 3 times the bracket, 5 minus x squared equals 210. Next, we need to expand that bracket. 5 minus x squared is 25 minus 10x plus x squared. Multiplying that entire bracket by 3, our equation becomes 2x squared plus 75 minus 30 plus 3x squared equals 210. Now, let's combine our like terms. 2x squared plus 3x squared gives us 5x squared. So we have 5x squared minus 30x plus 75 equals 210. To solve the quadratic, we need it to equal 0. We subtract 210 from both sides, which gives us 5x squared minus 30x minus 135 equals 0. To make the factoring easier, we can divide the entire equation by 5. This simplifies down to x squared minus 6, x minus 27 equals 0. Now we factor. We need two numbers that multiply to negative 27 and add to negative 6. Those numbers are negative 9 and positive 3. This gives us our two brackets, x minus 9 and x plus 3. So our x coordinates are x equals 9 and x equals negative 3. Finally, we find the corresponding y values by plugging these back into our line equation. Y equals 5 minus x. When x is 9, y is 5 minus 9, which is negative 4. When x is negative 3, y is 5 minus negative 3, which is 8. Therefore, our 2 points of intersection are 9, negative 4, and negative 3. Next, question 23. We need to simplify a complex fraction involving powers and square roots and give our answer in the form 5 to the power of w. To get there, our strategy is to convert every single term into a base of 5. First, let's look at the numerator. We have 30 times 25 to the power of 2x plus 7. We can write 30 as 6 times 5. Since 25 is 5 squared, we can rewrite that part as 5 squared to the power of 2x plus 7. Multiplying the exponents gives us 5 to the power of 4x plus 14. Putting it together, the numerator is 6 times 5 to the power of 1 times 5 to the power of 4x plus 14. Adding those powers of 5 gives us 6 times 5 to the power of 4, x plus 15. Now for the denominator, we have the square root of 180 times the square root of 5 to the power of 4x plus 9. Let's simplify the square root of 180 first. We can split 180 into 36 times 5. The square root of 36 is 6, so this becomes 6 square root of 5. In index form, that's 6 times 5 to the power of a half. Next, the square root of 5 to the power of 4 plus 9. Since the square root is a power of a half times 4 is 2, and a half times 9 is 4.5. So we can simplify it into 5 to the power of 4, x plus 4.5. Combining these, our denominator is 6 times 5 to the power of a half times 5 to the power of 4x plus 4.5. Adding those exponents gives us 6 times 5 to the power of 2x plus 5. Now let's put the whole fraction back together. We have 6 times 5 to the power of 4x plus 15 divided by 6 times 5 to the power of 2x plus 5. The 6's cancel out perfectly, leaving us with just our powers of 5. When we divide powers with the same base, we subtract the exponents. So our final exponent, w, is 4x plus 15 minus 2, x minus 5. It gives 2x plus 10. So our final answer is 5 to the power of 2, x plus 10. Let's work through question 24, part A. We have a quadrilateral OACB, and we are given 3 specific vectors. O to A is 4A, O to B is 3B, and B to C is 2A plus B. Our goal is to find the vector for the path A to C, expressed in terms of A and B. To get from A to C, we need to follow a roadmap using the paths we already know. A clear route would be to go from A back to the origin O, then from O to B, and finally from B to C. So our equation is vector A minus C equals A minus O plus O minus B plus B minus C. Now let's look at each segment. First, A to O. Since going from O to A is 4A, going the opposite direction from A to O is negative 4A. Next, O to B. We are told this is simply 3B. Finally, B to C. This is given as 2A plus B. Now we just need to add these all together. We have negative 4, A plus 3B plus 2A plus B. Let's combine the like terms. For the A terms, negative 4A plus 2A gives us negative 2A. For the B terms, 3B plus B gives us 4B. So our final vector for A to C is negative 2A plus 4B. Now let's work through question 24, part B. This part is a bit more involved. We have a point P on the line A to C, and we are told that O, P, and Q are collinear. Our mission is to find the vector O to Q in terms of A and B. First, let's locate point P. We are given the ratio A to P to C is 3 to 2. This means point P is 3/5 of the way along the line from A to C. Using our result from part A, we find the vector A minus P by taking 3 over 5 of our vector A minus C. This gives us negative 6 over 5, A plus 12 over 5B. Next, we find the vector from the origin to P, which is O minus P. We do this by going from O to A, then from A to P. Adding these together, we get 4A plus our vector for A minus P, simplified, O minus P equals 14,5 plus 12,5B. Now, here is the clever part. Since O, P, and Q are on the same straight line, the vector O minus Q must be some multiple of O minus P. Let's call this multiple n. So OQ equals n times our vector for OP. This gives us our first equation for OQ. But there's a second straight line to consider. B, C, and Q are also collinear. This means we can reach Q by going from O to B and then adding a multiple of the vector B minus C. Let's call this second multiple m. Now we have 2 different ways to write the same vector O to Q. By setting them equal to each other, we can compare the components of A and B. Comparing the A components, we find that n is equal to 5 over 7 of m. Substituting this into the comparison for the B components, we can solve for m. After a bit of algebraic balancing, we find that m equals 21 over 5. Finally, we plug this value of m back into our second equation for O minus Q. 2 times 21 over 5, it gives us 42 over 5a, and 3 plus 21 over 5b gives us 36 over 5b. So our final answer for OQ is 42 over 5a plus 36 over 5b. Finally, question 25. We have a sketch of the graph y equals 2 sine bracket 2x plus 60 degrees. Our task is to find the specific coordinates for points A and B. First, let's identify how the standard sine wave has been transformed. The number 2 multiplying the sine function stretches the graph vertically. This means the amplitude is now 2, the peaks reach up to y equals 2, and the troughs drop to negative 2. The plus 60 inside the bracket shifts the entire graph 60 degrees to the left along the x-axis. In a standard sine wave, the first peak occurs at 90 degrees, 1. To find point A on our new graph, we apply our transformations. We shift the x-coordinate 60 degrees to the left. 90 minus 60 equals 30. We apply the vertical stretch to the y-coordinate. 1 times 2 equals 2. So the coordinates of point A are 30 degrees, 2. Now, let's look at point B. On the sketch, B lies on the x-axis where the graph completes its cycle and returns to 0. We can solve this by looking at the standard 0 points of a sine wave. A standard wave returns to the x-axis at 360 degrees. Applying our horizontal shift of 60 degrees to the left, we subtract 60 from that 360-degree mark. 360 minus 60 equals 300. Since point B is sitting right on the x-axis, its y-coordinate is simply 0. So the coordinates of point B are 300 degrees, 0. Thank you for watching. Education made easy with Studia.